example of graphing a system of linear inequalities in standard form. And so once again, we are going to start by taking each of the inequalities and isolating for y so that we can have it in slope-intercept form. So I'm going to go ahead and do that right here. So this is the first equation. So what I would do first is I would add 5x to both sides. So I'd get 6y greater than or equal to 5x plus 12. And then I would divide by my coefficient of y to get y greater than or equal to 5/6 x plus 2. All right, and let's talk about our inequality here. This is a greater than or equal to, so we're going to be shading above this line, and we want it to be a solid line. So I'm going to come over here to the ALEKS program. I'm going to go to plus 2, and that's my y-intercept, and then from there I will go up 5 units and to the right 6 units. So this should be my line. All right, it's a solid line, and I'm going to be shading above. So I'm just going to kind of put some points out here to remind me that, hey, I'm shading somewhere up there, okay? All right, let's look at the second inequality. So we have 7x plus 3y is less than 12. So once again, I'm going to first move the x term to the other side to get 3y is less than negative 7x plus 12. And then I'm going to divide by the coefficient of y to get y is less than negative 7/3 x plus 4. And again, let's analyze this inequality. So notice I don't analyze the inequality until after I get it in the slope-intercept form, okay? And that's because if I were to have divided by, let's say, -3 instead of +3, let's pretend this was negative. Anytime you divide both sides by a negative number or multiply while you're solving, the inequality would actually switch. It would actually switch from a less than to a greater than. So just keep that in mind in case that comes up in some future examples, okay? But it didn't in this one. All right, and so we're going to shade below this line, and it's going to be a dashed line. So let's come over here. Positive 4 is the y-intercept, and the slope is down 7 and to the right 3. So this should be a point, and so let's connect those points, turn it into a dashed line, and we are shading below it. So below this line is anything in this area, these two areas, okay? But we said that we needed to be above the solid line and below the dashed line. So that means all of these points are solutions. So I'm just going to shade right there, okay? And this would be the graph. And if you wanted to, you can go back and erase any. Oops, I erased the whole line. Let's not do that. You can go back and you can erase all these little points if you'd like to make your graph look a little cleaner, but ALEKS doesn't mind. It doesn't count them as anything. It just thinks of them as little sketch marks to help you. All right, and so then it says, what is a point in the solution set? So it says, then give the coordinates of one point to the solution set. Well, you could pick any of these points, but you could also pick a point along the solid line. Now, we couldn't pick the intersection because the intersection includes a solid line and a dashed line, but I'm going to go ahead and pick a point on the solid line just to show you that you can. Let's do this y-intercept, 0, 2. And let's press check. And there it is. It's correct. All right, hopefully this was helpful for you.